kind of, it's number one, the second number one in optional realistic stuff. All right? And so this book stresses the Dirac notation, which is a matrix formalism. All right? It's an undergraduate book. All right? So when I got here, when I first got here, I said, I want to do the matrix representation. All right, so I taught the matrix representation, and we had a student here that graduated, went to Colorado State, and just was crushed at Colorado State because he said, what is a wave function? All right, he just did this, he just did the matrix representation. All right, so that killed me, that really upset me. So what I did is I said, look, what I'm going to do is I'm going to switch, and I'm going to go back to the wave function formalism. All right? And the reason that I went back to that is because if you look across the country and at the best curricula everywhere, even though I was trying to push the curriculum to be better and do this, which is kind of a more modern approach, if you look at like all the best colleges and universities for undergraduate physics, they're doing, the majority are doing the wave formalism, and almost all of them are doing this book by Griffiths, with the cat dead and alive. All right? So of course, as soon as we do this for a while, you know, then one student goes out to graduate school and said, I needed more of the matrix formalism. All right? So the long and the short of it is you need both to be successful in graduate school. All right? And so you just have to know they're both out there. And the truth of the matter is the one that had the wave function formalism was very easily able to transform over to this formalism. So probably that's the best way to do it. Right? Everybody see my logic? And so if you go to the best places in the country, this is almost overwhelmingly what's being taught. Not everywhere, but almost overwhelmingly. All right? So if you go into graduate school, we're going to get through half of this book, which is what you do across the country. All right? At some schools, you get to do the second half, and that's quantum 2, and we teach quantum 2. I do quantum 2. All right? And if you want to be successful in graduate school, I suggest completely you get through quantum 1 and quantum 2. Otherwise, you're going to be in deep trouble, and you'll have to really work twice as hard in graduate school. All right? Right now, if you want, Louis, who's at Brandeis this year and is doing very well, he took not only quantum 1 and quantum 2, but he also took quantum 3. All right? And so we could go to quantum 3. Quantum 3 is even more. Right? So my advice is to do as much quantum as you can. Right? But you don't have to. I mean, as physicists, you know everything's up to you. So if you only have quantum 1 and you go to graduate school, just work hard. Right? Because it's all up to you anyway. It's not up to us. It's not up to the person standing in front of here. It's not going to be, in graduate school, it's not going to be the person in front of the class that teaches you. You teach yourself. Okay? Good. All right. So that's my motivation for these two books. And they're great books. The truth, so in here we do touch on some of the Dirac and the matrix stuff. We do touch on it. All right? So it's not devoid of that other representation. It is in there. That's kind of why I wanted this. As is this one. This one's not devoid of the wave formalism. The other reason that a lot of people like to do this is that the wave formalism gives you a little bit of a picture. It's kind of interesting. Schrodinger always fought for the wave formalism because he said I can have a physical picture of what's going on. All right? And Heisenberg, on the other hand, said there is no physical picture. Why should I force a physical picture when there is none? I'm just doing math. And because the wave function formalism falls apart in some place, it's not right. So there is no real physical picture of quantum mechanics. Nobody understands quantum mechanics. Right? We have mechanisms that work, and we have some ballpark ideas, and some like ways to describe it. But at some point, here's an important point that I talk to philosophers and everything about. At some point, your experiences of the world, your words of the world are no good and won't help you, and in fact will mislead you when you're doing quantum mechanics. All right? So that at some point our need to say, oh, I would like to have this physical picture is going to fall apart. It won't work because we don't have one. Right? We're born macroscopic objects, 10 to the 23. we don't have any experience, we don't have any language, we don't have good descriptions for what goes on the quantum level, except for quantum mechanics itself, which is very much a mathematical experience. So what I always say is if you truly want to experience physics and particle physics, you really experience it at a mathematical level. All right? And for people that don't like math and physics, they say, oh, that's very boring, it's very restrictive. But if you really look at it, it's the complete opposite. If you do math and you do physics, what you're doing is you're liberating yourself from your classical experiences and the classical words. You've got more than that. And so if you can do math and physics, you're really liberating yourself to all these possibilities that the rest of the world don't have. Right? So I always turn it on a very positive way, and I truly believe that. I mean, you guys will experience things that the greatest poets and philosophers don't, unless they work hard and do this stuff as well. Right? Okay, so those are the two books. Now, what I always say is you got to pack yourself when you're doing quantum mechanics with a very good modern physics book. This is a very good modern physics book. It's the modern physics book I use here. All right, and it's by Harris. I like it a lot. He does stuff on Schrodinger's equation in quantum mechanics. So if you get stuck in Griffiths, pull out this. You'll get pictures and some nice words that are going to help you, and maybe it will have mathematical things that are explained out better than what Griffiths does. So this book is indispensable in my opinion. All right. Now it just so happens Townsend of the Green Book also has this year a modern physics book. Right? And his modern physics book is very much the same approach as this book. So it's also a very good modern physics book, and it also has very good stuff for that picture, the Dirac matrix forms. Right? So I think I need to explain those things so you know where we're coming from, where the books are at. This is the only book you're required to do here, Griffiths. All right? Everybody cool? Okay, so that's the books. There's some other ones, like the optional dream stuff is great. If you like this stuff, there's just great stuff. There's also crap out there, right? So anybody can publish a book. So there's crap out there and legit stuff out there. All right. My friend Mario, who did his PhD with me at the University of Connecticut, he did quantum chromodynamics, which is the gluon-gluon interactions between quarks. And so he's at a college called Davidson College in North Carolina. It's a very nice school. It's a very nice school. Yeah. And he does these things called physlets. Right? And essentially there's simulations. And so he has these simulations in quantum mechanics. So when we do solve for wave functions and wave packets and stuff like that, he's got these simulations that you can run through. And some people find those things useful. All right? So if you want to go there, and he has a book too if you want to get that. But here's my scoop, is that here's what I found. Even in introductory physics, like all the stuff you do on the web and all the interactive things you do on the computer, that they're ridiculous. All right? It's like having a movie. It's like watching a movie. Right? In a movie, you can do whatever you want. You can superpose things and lie and not have things that are physical, right? And you're just watching a movie and you don't know any better. So what happens when you're doing these simulations on the computer, right? Unless you know the physics underneath the simulation, right? You're getting experience with crap physics. Like for example, if I put in my simulation the gravity doesn't point down and it points slightly that way, right? And you watch these simulations, you watch a block slide down an incline and you go, oh, okay, I get it, I get these concepts. Right? So you don't learn by watching. You don't learn by watching TV, and so Jeremy, I was going to talk to you about that. So it's very nice to get people interested, but to learn physics, you can't do anything but do the math, I'd say, and do the equations. All right, TV and movies and videos are fun, but it's not going to do it. All right, I know our generation wants to watch something on TV for 15 minutes and be educated about it, but that doesn't work. All right, in my opinion, I could be completely wrong. All right, so anyway, but my friend Mario spent a lot of time on those things, and in fact, I'm quoted on the back of his book saying how good they are, and now I've completely changed against them, and I think they're very bad. So I think if you guys wrote the code to make simulations work, that would be a very good experience and you would learn a lot. But you guys sitting there watching somebody else's code is, for all intents and purposes, meaningless. So he hasn't asked me to put in quotes on his books lately. All right? All right. So how things work, you grade, we'll have 3 exams. All right? And then a final exam, and then homework. Everything is essentially 20%. The exams will be, one shot at a time. So the first third of the course, exam 1, second third, exam 2, third, exam 3, and then the final will be cumulative. All right, and everything's worth 20%. I always have closed books, closed notes exams. All right, so what I always think is that as a physicist, you should be able to write down F equals ma and get somewhere. And quantum mechanics, I always think you should be able to write down Schrodinger's equation and get somewhere. You don't need to look at a book, right? And so that means you need a lot of tools. You need Taylor series expansions at your fingertips. You need to know how to take derivatives and integrals at your fingertips, all right? So, not killer integrals, not killer derivatives and things like that, but definitely product rules. You should know how to integrate and differentiate exponentials. And then there are more. Like I think everybody should be able to integrate by substitution. I think everybody should be able to integrate by parts. And then after that, you can look at books or use software. Right. So it'll be closed books and closed notes. Here's how I might do it. I might do it this way. Instead of saying do exam in the class, I will send you home and I'll say take 2 hours and do it at home. And you will write down the time when you start. You write down the time when you went, and you will sign a thing that you didn't cheat and you obeyed by my honor, which was to take 2 hours of continuous time, where you didn't open any books, and you did that. And so your signature is telling me that you live by the honor. And if you want to take extra time, say, look, I ended here, here's how much extra time I took. And I'll say, okay, thanks, after that. All right, that's the way I do it. All right, final exam is everything. Homework, so I'll give you your homeworks. And so they'll be in class. It's not my job to keep track of what homeworks I assign. It's your job. All right, so if in class I just say, oh, do this, all right, that's your job to do that. Someone will remember, and when that someone remembers and turns it in, then I'll say, oh yeah, that's what I assigned, and then everybody else will get a 0. Right? That's kind of how it goes. So it's your job. Right? The other thing with homeworks is I always think that if I'm giving all the bad stuff here. So here's how I feel about homeworks. You should be insulted that homeworks are turned in. Right? With that, so here's how it works. If I give you homework, you should go do it. If you have any questions about it, you can't get it, you should ask me. That's how homework should work. All right? But what you guys are used to is me giving you a homework, and then you guys turning it in, and then me giving you a grade for it to make sure that you did it. All right? Well, I kind of go in the middle. I'll give you a homework assignment, and turn it in. I will spend no time correcting it. I will look at it and give you like somewhere between a 0 and 10 based on how much work you did. And I'll spend all of about 3 seconds or less on your homework and then hand it back. All right, so when you get it back, you may have a lot of stuff and I gave you a 10, but you may not have it right or wrong. Right? So then it will be your job to go and find out if you got it right or wrong. And so what I'll do is I'll post the solutions. All right, and here's my philosophy there. To do any type of thinking is hard. And so if you go and you do work and you just do something and it comes out wrong and you give it to me, I'm the one that's got to think really hard to figure out why it is that you were led wrong and then how it is to get you back on the path. That's a lot of work for me, right? And what happens is I get better at it because I've done all that work. But you guys don't get any better because you haven't gone through the process of banging your head and figuring out where it is that you went astray.